So let's start. So as I mentioned in today's class, okay, I see somebody named Shalini. Who's Shalini? Okay, all right. That should be Vaibhav. Anyways, so let's get started. So in today's class, we are going to learn, or we're going to start learning probability, permutation, and combination. And I'm pretty sure many of you would have learned this in different shape and form. So let's, for those of you for whom it is known, it'll be a recap. For some of you who have not used that enough, it'll be a fresh start. Yeah. So, like we always do, when we say probability, what does it exactly mean? And tell me in simplest form that you can express. Anybody? Yeah.
The chances of something happening.
A chance of something happening. Anything else that comes to your mind? Anybody in the class? And I would certainly suggest everybody to be equally participative, and you must engage in the class, because that is when the fun starts. So probability in simple terms is nothing but chance of something happening. Now let's say you toss a coin. Can we predict whether it will be head or tail? Which one is more likely? Yes, Arya.
It's a 50-50 chance.
It's a 50-50 chance. And that's the reason why before any game starts, people toss the coin to decide who goes first. Had it been something predictable, that would have been called match fixing, right? So probability, again, in simplest form, it is nothing but the chance of something happening. Okay, so when you toss a coin, you can get a head or tail, depending on whose day it is. You roll a dice, which again has 6 possibilities. On every side you have some numbers written, and there are 3 more sides that we are not able to see on the board right now, but like we have 1, 2, 3, we have 4, 5, 6 also written on each of the sides. So if you look at this is nothing but a cube for you, where you have one side here, let's say this is 2, then you have a side on the back, the shaded one, maybe it has a 4 dots, this side maybe has 5, let's say, and the bottom side which is not visible from here, that is probably having 6 dots into it. So every such event where the outcome is not known, we end up guessing based on certain reasoning around it, which is called probability, right? So like most of you said, it's not. Hey, what's up? I still see Vaibhav is missing, but it could be because of the festival season. Some of you are getting ready for Diwali, some are getting ready for Halloween. Alright, so basically probability is nothing but it describes a situation or scenario where you end up leaving something to chance, and chance and probability are the 2 terms which can be used interchangeably. So now let's look at what exactly we are going to learn. So all that we talked about, that was the theory part of it. You toss a coin, you can get a head or a tail. You roll a dice, you might get anything from 1 to 6, and there could be different combinations of things. So which we'll talk about. So which is again part of the topic, right? Combinations. We will talk about that. And similarly, there's another term that we'll talk about in next few classes. I'm not going to rush and finish probability, permutation, combination, everything in one class. That will be probably an overdose. So we'll go slow, but make sure that whatever we do, we grasp it the maximum extent. So now, when we're talking about probability, we understood it's nothing but chance. What is exactly permutation? Permutation. Can anybody tell me the basic definition of that, or understanding of what a permutation could be? Anybody? Permutation. I'm assuming that you have heard this term. Chris, Dev, Arya, Dhanusri, anybody? Ananya? Krisha? Anybody? I mean, just give me the simplest and the easiest definition of what a permutation is. I mean, let's say if you assume I'm a 5-year-old child, which is not the case though, but still, if you assume that, no, if you have to explain this to a 5-year-old child, how would you explain what permutation is? And that reminds me, Arya, where is Aryan?
Oh, he has an event to be
Okay. All right. Yeah. So yeah, coming back to the point, how do you explain or make me understand, and I'm a 5-year-old child, to everybody's surprise, what a permutation is? You all remember the bad times that we went through, right? The COVID. And you would have heard a term, the virus is mutating. Did you? And what that mutating means, when you say mutate, what happens is it creates different versions of it. So permutation is something that you can relate with that word mutating. Okay. Where now let's look at a situation first. Maybe I gave you guys a tough ask of describing what permutation is. Let's hold on to that definition of permutation for a little bit, and let's look at a practical scenario. Let's say I have 3 chairs. Chair 1, chair 2, and chair 3. I know it doesn't look like a chair. I will make it look like a chair though. Let's see. Okay. Now these are 3 chairs. Okay. Okay. There are 3 chairs. This is chair 3. And you have three people. People 1, people 2, and people 3. This is one way everybody can take a chair. Okay. Yeah. Now, meaning I can make the first person sit on the first chair, second person on the second chair, third person on the third chair. Now, I wanted to have more fun with this. Hello, Sarah. Hi, Neil.
Hi.
So we just started probability, permutation, combination. This is a topic for next few days. Maybe today, tomorrow, or in worst case scenario, it might go to next week also. But we have just started the definition of what probability is. Probability is nothing but chance, and we'll come to that. We have not done much of work so far. We are just trying to understand what is a permutation. So when I was saying that there are 3 chairs, chair 1, chair 2, and chair 3, I have 3 people, person 1, people 1, people 2, and people 3. I can make them sit like this. So first person takes the first chair, second person takes the second chair, third person takes the third chair. Now, I'm not a person who is always happy with what he has. No, why not person 2 on first chair? Okay, I can take 4. I can make the second person sit on the first chair. Now I have 2 options between P1 and P3 to go onto this chair. Let me see. Okay, this time I will make the person 1 sit on the second chair, and person 3 remains in the seat. Again, not happy like always. Okay, let me keep person 2 here, but these 2 people I can juggle with. Maybe I'll make the person 3 sit on this chair, person 1 sits here. So likewise, I can just go on. But what I'm trying to say here is these are the different ways you are mutating the seating possibility. This is how, when we said that the coronavirus is mutating, what we meant was the chemical composition of the coronavirus was kind of shuffling among itself. Let's say, I'm just making it up, I don't think I'm qualified enough to talk about it. Let's say COVID, the coronavirus had, let's say, 3 substances, A, B and C. So the scientists found that, okay, A, B and C, first A, then B and then C, these 3 things are put together is making the coronavirus. But then coronavirus turned out to be smarter than the people. Say, okay, now you were attacking A and then B and then C to kill me. Now I change my front end. Now you find out another vaccine. Because everything happens in a sequential manner, right? I mean, if you have to kill that COVID, I mean, I'm just making it up. The vaccine was designed that, it will first kill A to make it weak, then B and C. It did not know how to kill B first. The coronavirus turned out to be smarter. I said, okay, fine, you knew how to kill A and then penetrate inside to destroy me. Now, I'm giving you a problem to deal with that you don't know how to handle or to begin with. So this is where the combination, the chemical composition of the coronavirus itself was mutating, meaning it was changing the sequence or the way it was organized, so that every combination, ABC versus BSC, are 2 different viruses actually. I mean, if you look at it from science point of view. Science knew how to kill this guy, but not this guy. Not this guy either. So when the coronavirus started mutating, it became more difficult for scientists to figure out, or the medicine practitioners to figure out, if some medicine works on this one, this will not work on this one and this one. Likewise, if you have a medicine that works on this one, would not know how to deal with this or this. So the coronavirus was mutating meaning changing its whole structure itself, right? So in real life, when you talk about permutation, you're essentially talking about mutating your combination or mutating your whole structure, mutating the way you're organized. That's why it's called permutation. So far, relatable, not relatable?
Yeah, makes sense, sir.
Yeah. All right. And I gave you guys one of the most dangerous or not so likable reference, but certainly it's relatable. I mean, you can relate. I mean, whenever next time when you hear about the word mutating, at least you would be able to relate to the story that I told you guys. So permutation is nothing but it's a way you can create different combinations from a group of things that you have. So we talked about what is probability at concept level. We talked about what is permutation, and next thing is combination. Do we really need to talk about it? Combination is combination, right? Where A first, B second, or A and B combination versus A, B and C combination. So combination is a simpler, easier English word. So we are not going to spend time on decoding the English word. When it comes to solving the problems, that is when we'll deal with it. Okay. So basic definition of what is probability, what is permutation, what is combination. Just we got a fair understanding what exactly it is, and then we'll go on to the next level of things. Now, anybody, before I move on and talk about little more complex things than what we have talked about so far, any questions, anybody? And I have a very bad habit of putting people on the spot. So how about you, Krisha? Are you able to follow me so far?
Yes, I'm able to follow.
Wonderful. Yeah, Chris, go ahead.
I just had a question. What is the difference between permutation and combination?
So there's a very thin line. There's actually a very thin line, right? The way I described permutation. it also means that how things are organized, how the this combination versus this combination is coming into play, right? But when you look at permutation, permutation is it's more like you have same number of things to arrange and you are juggling with the combination. I mean their sequence or the positioning of the things. That is where you talk about permutation. You are not changing the number of elements. You are always looking at this. But when you talk about combination, that is when you say, okay, fine, I have, let's say, 4 fruits: apple, banana, guava, and let's say pineapple. Here, if you're talking about permutation, you will talk about juggling them. Something comes first, something comes next, kind of thing. But when you talk about combination, that is when you will talk about how many different types of salads you can make out of these 4 fruits. You'll say, okay, I'll make one salad with A and B combination. I'll make another salad with B, G and P combination. I'm wanting to do more adventure, make a salad with all 4 of them. Apple, banana, grapes or guava and pineapple. So when you're talking about combination, you're essentially talking about forming different combination out of the elements that you have. So it could be one, it could be many, it could be all of them, or different what you call different picking you will have from what you have at your disposal. Yes, Dev. So before I go to Dev, Chris, is that making sense or I got you confused?
That does make sense. Thank
Okay.
you.
Yep. Yeah, Dev. Go ahead.
Wait, for an example, just to clarify, is permutation like where you have to use all of the like objects, where combination is like you can only use some? Is that like a differentiating factor?
Yes, some or all of them, depending on how you want to choose them.
Okay, thank you.
So in case of permutation, the order matters. In case of combination, doesn't. It's the number that matters. Yeah.
Yeah, thank you.
Anybody else in the class? If I have purposefully confused any of you, please let me know. Sunarka, are you with me?
Yes, sir.
Rehan, any doubt?
No, sir.
No. Neil, Sarah?
No, sir.
Okay. Dhanushri, anything that is giving you a reason to doubt my skills?
No, sir.
No? Okay. All right. So now let's start venturing into what we have just talked as English. So let's go to the mathematical part of it. So whatever we talked about, that okay, probability is nothing but a chance. But let's say I go for an exam and I will say I got 20% in my exam or I got 80% in my exam, was all because of chance. Eventually that is not the case. I will get what I am prepared for, what I have, how much I have prepared, or did I prepare for all the topics that were supposed to come in the exam, right? So there's a science behind that. None of us do good or bad just because of anything else. It's always because of how well we are prepared for what we do. So same way, if I leave probability to chance, none of you will score good. So let's go into the mathematical side of it and start dealing with it. Let's look at some practical examples. Probability in mathematics gives you a science behind or an approach behind that to kind of make your mind with respect to how far or close you are from what your desired results are. Okay, so now let's look at a simple scenario to begin with. I have a coin. Let's say I don't study, I only play cricket. Like any other Indian child, we all have played cricket. And I'm not sure if you guys get a chance to play cricket here, but yeah, knowing that it's more of a religion in India, I'm saying that okay, We all know what a cricket is. So we all, let's say I went to play cricket. I am the captain of a team, and I have, let's say, Praneeth as another captain from the opponent team. And we know that on that ground, whoever bats first wins. So everybody is wanting to win. We toss the coin and I called for head. Will I get a head? Maybe, may not be. Because the coin has two sides, like every other coin. One side is head, another side is tail. If I get a head, I will win. If I don't get a head, Praneeth wins. The chance of getting a head is one chance, and chance of getting a tail is also another chance. So if you look at them in totality, you'll say, okay, this guy has 1 out of 2 chances, and this guy also has 1 out of 2 chances. Depending on whose day it is, who has done more worship, who has prayed God hard enough, probably ends up winning it. There is no other way to predict it. So both have equal chances, right? That's where the game is fair. Anybody can win. So now, if you look at it mathematically, meaning if you have a coin to toss, whether you will get a head or a tail, both are equally likely, 1 out of 2. Tail can come 1 out of 2, head can come 1 out of 2. So this is 0.5, half a chance. This is also half a chance. And you can say that in percentage also, that okay, chance of getting a tail is 50%, chance of getting a head is also 50%. This is just the warm up, right? Whatever we are talking about. Now, let's say if it, since it gets more tricky just with one toss of the coin, the organizer decided, okay, we'll toss the coin 5 times, and whoever wins maximum times goes for this. Meaning, same coin, if you toss 1 time, you can get a head or a tail. Second time, again you toss, you can get a head or a tail. So, let's say you have a coin, first time when you toss, you can get a head or a tail, or a tail or a head. Let's say second time, when you, I don't think this is the right way to put it. Let me make it simple. This is head, this is tail. First time, what is the possibility of getting a head? It is again 0.5 or half. This also has half. Second time when you toss, same thing, doesn't change. This is a possibility. Third time when you toss, doesn't change. Fourth time when you toss, possibility remains the same. 5 times when you toss, let's say it happens the same way. All have equal possibilities. But then, all have equal possibility. In the first toss, let's say it came as head. One will come, let's say head came. Second time also, let's say head came. Then came tail, and then tail, or maybe head. So just by looking at all the combinations, when you toss the coin 1 time versus multiple times, you can look at it doesn't remain the same 50% if you have 2 options. It becomes a combination of few of them, because it's very unlikely that all head will come or all tail will come, or it will be equal distribution. So depending on the luck, different values come, different outcome comes. So here let's look at another situation. Okay, so I'm purposefully trying to get you all confused, and then I'll try giving a solution so that you are able to relate. So now let's say when I'm tossing 1 coin 1 time, what is the possibility of getting head? When I'm tossing it 1 time, I'm getting a possibility of getting a head or a tail is this. I can get head or tail. Now, let's say I toss 2 times. What will happen? I can get head on the first attempt. I can get tail on the first attempt. This is one chance. Or I can get a tail in the first attempt, then I can get a head in the second attempt. I'm tossing 2 times, okay? Or I can get a tail in the first attempt, okay? I cannot get any other combination. So I can get head in the first attempt, I can get tail in the attempt, or second attempt, or I can get tail in the first attempt and I get a head in the second attempt. So let me kind of collect the thoughts and tell you. I have coin, I am tossing it 2 times. And what we are trying to see here is what are the different possibilities that I will come across. When I am tossing it only twice, I can get a head or tail or a head in the first and second attempts respectively. So, let me think how I can present this to you guys. Okay, so yeah. So when I'm, yeah, Dev.
Wait, I just had a question. If we toss it twice, right?
Mhm.
Why can't tail and head also be a possibility?
Yeah, so you are actually connecting the dots. What I was not doing in the first go is where you are making me extend the table, right? So let's now you have started going a little ahead of me. So here what I'm trying to say is, if you have a coin to be tossed twice, how many different possibilities you can come across? This is 4. Now extend this further, and whatever I'm doing right now, that will help us derive a mathematical outcome from this whole discussion. So I had a coin which I am tossing 2 times, and these are the possible combinations I can get: head or a tail in the first and second attempt, tail or a head in the first and second attempt, both attempts getting tail or head. Now look at a third combination where the same coin is tossed thrice. Then what are the possible options we can get? Tail, head, tail, head. So kept tail in the first place and then juggle with. One second. Okay. So I kept tail in the first place and then both coming tail or head and tail and head, and other one is other two being head. Same way, I will put a head in the first place and then see what are the options that I can get, and then I can get okay. Now, yeah. So these are options that I am getting by tossing it 2 times or 3 times. Now let's look at how do you relate it. How do we relate this one? So in the first scenario, when you have one coin to be tossed twice. The other 4 options you are getting. Second scenario, same coin, if tossed 3 times, the other different options we are getting. Just tell me if you are missing anything. No, we are not missing anything. So, I have a formula ready for giving it to you guys, but I always stay away from the formula, right? So, I will not give the formula in the first go. Now, let's look at this in something called a tree form. Okay? Meaning, look at this option. If my first attempt is head, what all I can get? Tail or head. When my first attempt is tail, what I can get is tail or a head in the second attempt. Okay? So this makes it head-tail combination, head-head combination, tail-tail combination, tail-head combination. This is what you see here. You are putting your first attempt as head and second attempt as tail. Sorry, first attempt as head and first attempt as tail, and then you're looking at what your possible options could be. So look at this. This one, head, tail. This is your combination. Tail, head. Tail, tail, head. This is your combination. Tail, tail. This is your third combination. Head, head is your fourth combination. So this is called the tree structure, where you pick one as a base and see what are the alternate combinations you have. Here, if you look at it, you have, here also you can put that like a tree. Okay, first option is tail, and then our first option is head, and look at different options. So first option is first outcome is tail, and this is first outcome is head. When first outcome is tail, you can get a tail or a head in the second outcome. When head, again you can get head and tail, and then when second outcome is tail, again in the third outcome you can get a tail or a head. Here also you can get a tail or a head. Here also you can get tail or a head. Here also you can get tail or a head. Now this becomes like this: 1, 2, 3. This is your one combination. 1, 2, 3. This is your second combination. 1, 2, 3. This is your third combination. 1, 2, 3. This is your fourth combination. Similarly, 1, 2, 3. One combination. 1, 2, 3. Fifth combination. Sorry, fifth, sixth, seventh, eighth. So this is why you see 8 combinations here. But all that I'm doing on the board, there is a reason to it. Yeah, Chris.
Wait, so if you just keep on like adding like heads in, like in the tree structure, the one you drew on the left, like if you just keep on adding like heads and tails, does that just like go into infinity?
No, it will not. So from this, I'm trying to give you guys a conclusive outcome from this one. Okay. Now, look at this one. If I have the coin, I can get 2 possible outcomes. Okay. Every coin, when I toss, I can get 2 outcomes. Every toss will get me 2 outcomes. Agreed? Or can get me 2 outcomes. Right? Now, when I'm tossing it 2 times, meaning I'm getting 2 into 2, that many outcomes. 1, 2, 3, 4. Here if you look at this one, I had one coin which can get me 2 outcomes, and am I missing something here? TTH.
2 to the power of 3.
Huh?
2 to the power of 3. Okay, true. Total.
Yeah. No. And I'm just trying to make sure that I'm not missing anything here. Yeah. So from here, if you see, I'm just making sure that I'm not missing anything here. If you have a coin which can give you, every toss can give you two outcomes, and if you are tossing it two times, what you are getting is 2 times 2, this many outcomes. If you have this one coin which you are tossing 3 times, how many possible outcomes you are getting?
8.
You are getting 8. Okay. And now let's look at one more example before we can formulate this one. But a quick summary of this, okay, is if you have some, let's say we are talking about possibility again, and we are looking at the relatable possibility, meaning if I am getting something in the first place, what are the options I have for the other 2 places, or how many possible combinations we can see. Okay, so now let's look at one more example before I tell you the magic formula. Okay, let's say you have to buy a car. Okay, you can buy either, let's say, Toyota or Honda. There are 2 options you have, and every car, to be Toyota or Honda, it comes in, let's say, 2 colors, black and let's say red. So what are the options that you have? You can buy a Toyota with a black, Toyota with a red, Honda with a black, Honda with a red. Okay, so you basically have Toyota black, Honda black, Toyota red, Honda red. This is one option. The other 4 possible options you have. Or if I say that you have either combination, another possibility where this is the brand, the colors, and then you have 2-wheel drive or 4-wheel drive options. And I'm talking about the same model, a similar model. I'm not going from a sedan to SUV or to hatchback or things like that. I'm saying you are planning to buy in a particular segment, either Toyota or Honda. Both of them come in black or red, and then you have the option to choose a 2-wheel drive or a 4-wheel drive. How many possible options you have that you can choose from? You can choose Toyota black and 2-wheel. You can buy Toyota black 4-wheel. You can buy Toyota red 2-wheel. You can buy Toyota black 4-wheel. Or you can buy Honda black.
You already did Toyota 4.
So basically same thing twice.
You already did Toyota 4.
I'm going to Honda now.
No, you repeated the last one.
No, this is
Second one and the last one.
okay. This is red. Okay, I just wrote it by mistake. And then same thing will repeat for Honda also. So this is where the tree structure comes into play. Instead of doing this, what you will do is, okay, I have these options. Toyota is one option where I can go black or red. And then with every segment I have 2-wheel, 4-wheel drive. Here also 2-wheel, 4-wheel drive. And then Honda also have the same option, black or red. 2-wheel, 4-wheel, 2-wheel, 4-wheel. So this is just a tree structure. What I'm trying to derive from here is, when you have different options to choose from, you end up multiplying these options. 2 models, 2 colors, and every color has 2 options. instead of making this tree, which is more for understanding purpose, what will happen is, if you count these things, this is one path, two path, third path, fourth path, fifth path, sixth path, seventh path, eighth path. So here you have two options, this is 2. Here you have two options, this is 2. And here you have two options, this is 2. If you multiply these 3, you can see the number of paths are matching here. So when you have different combinations to choose from, different possible values for different sequence, right? I mean, this is again the same thing, like the permutation part I was talking about. When you have Toyota black 2-wheel, so this is one permutation. Toyota black 4-wheel, this is second combination. We are not saying okay Toyota black and no wheel. So we are not talking about combination is combination. We are talking about the permutation, like how many options you have and which option you want to choose without compromising on the number of features that you have to pick from. And I know this might have got a little confusing, but we are just trying to formulate something from what we have seen so far, and then we will make a magical formula out of it. But whatever I have told so far, is there anything which is sounding cryptic or not easy to understand? Okay, there might be something confusing, okay, because I myself feel that I have made it a little cryptic. That's okay. So let's look at all the things that we have done together. Okay. We talked about first scenario where I have a coin to toss two times. Okay. Coin that I tossed 3 times. Okay. In this case, we saw, okay, fine, I can get head, tail, 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 head, 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 tail. Basically, every toss of the coin had 2 options and we tossed it 2 times. That is how we got 4 values here. Now, here we are tossing it 3 times. That means first level, okay, so basically head or tail, and then second time had 2 options, and again third time had 2 options. So basically this level you had 2 options, and for every of them you had 2 options, and for again every option that you got in the second attempt you had 2 options. That is how it became 8. Now when you relate that with the car option that we are seeing, where you had Toyota or Honda, and for every model you had black and red as 2 options, and again between the color options you could choose 2-wheel drive or 4-wheel drive. And that is how, when we saw this tree structure, Toyota, Honda, black, red, two-wheel, 4-wheel, 4, 2, 4, 2, 4. What we saw was first level had 2 options, second level also had 2 options, and third level also had 2 options. Among every color we had 2 options that we could choose. So that is how it became 8 options. Imagine if you had 4-wheel, 2-wheel and 6-wheel drive, then you would have 2 options and then 3 options here. So this would have become 3, and that would have given you a different number of possibilities that you have. Am I making sense now? Are you able to relate with the 3 options that I have put on the table, on the board?
I have a question.
Yes, Vinay. Yeah, Vinay.
Wait, did you write? Wait, I read page 3. Did you write coin? What is
Say that again.
and what is the third word you wrote? Car?
Car, yeah.
Oh, never mind.
Yeah.
Okay.
So basically, in this, yeah, Chris.
So this option thing that we're doing, like if you add like like Toyota, Honda, Black Red, 2-wheeler, 4-wheeler, like are these like outputs combinations or permutations?
So these are giving you permutations, right? So we are not saying that Toyota black, that's it. We are not saying that. We are saying Toyota black, 2-wheel, 4-wheel or 6-wheel. I mean, I have never heard of a 6-wheel drive, but I'm just telling you, hypothetically. So these are giving you different. So let's keep aside the word permutation for a little bit. What we are trying to say is, if I have these many options, what are the different possibilities or what are the different probability of options to choose from? So we have not gone to permutation calculation yet. I'm saying I have these options. Let's say I'm tossing a coin 2 times. What are the different possibilities I have? How many outputs I can get? By tossing the coin twice, every toss can get me 2 options, two outcomes. So I multiply 2 into 2. Similarly, when I'm tossing the coin 3 times, that means every toss of the coin can give me 2 possible outcomes. So first 2 multiplied by 2 multiplied by 2. If I was tossing twice, first number of outcome multiplied by second number of outcome is what is giving me total count of possible outcomes. Here it gave me this, and there was a chance that it could have gotten biased that okay, every time I have to multiply by 2. So that's why I chose this third option where I'm saying okay, I have 2 cars to choose from, and every car model, every brand gives me 2 color options, and within the color options also I can choose 2-wheel, 4-wheel or 6-wheel drive. So what are the number of possible combinations? What are the number of possible options? Let's not use permutation and combination purposefully for now. I'm saying what are the number of possible options from which I can pick. So now if I extend this further, if I'm saying that, let me check if I have explained this good enough for you guys. So I'm checking myself, not you guys, okay? But I'll be asking questions to you. Now imagine I have four car brands to pick from, okay? Honda, Ford, Toyota, and let's say Volkswagen, okay? And each of the car model, each of the car brand gives me 3 color combinations: black, red, and white. Okay, and then among all these variants, I have either 2-wheel drive or 4-wheel drive. Now, tell me how many options I have from which I can pick.
16.
You rest for the answer.
It's 2 W's. It's 24. 3 colors, right?
Yeah.
So that's 4 times 3 times 2, which is
How much? Okay. So again, I want to know if I have some money and I'm planning to buy a car. I got to choose between. I have decided on I'll go for only these 4 brands: Honda, Ford, Toyota, or Volkswagen. I cannot afford a Mercedes or a BMW, let's say. So, and in each of the brands, I have 3 colors that I can choose from: black, red, and white. And once I decide on the color, I have 2 options with respect to the 2-wheel drive or 4-wheel drive. So now how many options do I have? What are the number of probable options? Let's consider this as only as a probability question. How many options do I have that I can choose from? I got one answer in the classroom, but I don't want to tell the answer so that you guys get biased. Yes, Chris.
Would it be 24? Maybe 24 options.
Okay, that is one answer. I will come back to you, Chris, just to understand what is the reasoning behind the number. Sunarka, any guesses? Any thoughts around this one? How many options do I have to choose from?
I'm still trying to figure it out.
Okay. Dhanushri, Arya, Nanya, anybody?
I have a question.
Yeah, Krisa.
So there's how many options are there?
I'm just that's what I'm trying to figure out from you guys, because
No, I mean like how many? Like is there a 4-wheel, 2-wheel? Like how many?
So I have so again I'm repeating the question. I have decided. I have nailed it down to these 4 car models or car brands: Honda, Ford, Toyota, or Volkswagen. I'll choose one of the 4 brands. Okay, and then I have 3 color options available from these brands: black, red, and white. And among these color options, I can go for a 2-wheel drive or I can go for a 4-wheel drive. So just to tell you guys, I can go for Honda black color with 2-wheel drive. That is one of my options. I want to know how many total options I have. And again, I'm trying to get the answer from you guys to gauge if whatever I've explained so far, did I explain it good enough for you guys to be able to relate? And if I get a wrong answer, that's a bad sign, not for you guys, but for me. Arya, any guess?
I'm not sure, sir.
Okay. Dhanushri? Dev?
No, sir.
Okay. Fine. So that means I'm not a good teacher. Let me do my job one more time. So Chris, you gave me answer 24. Do you want to tell me what is your thought around getting that number?
Whatever you taught us till now, I just so you were like how many ever options you had, you were just multiplying those together. So then first of all we had 4 brand options, which was 4. Then we had 3 color options, and then we have 2 dealer options. So then all I did was 4 times 3 times 2, and I got 24.
Correct. So same thing Pranit also did. So let me kind of decode that in a much more simpler way. And trust me, see, permutation, combination, and probability are not difficult topics, but the effort has to go in making sure that we understand that conceptually in a better way. Now let's peel off the onions. Everybody ready to peel off the onions, right? Okay. Now let's say I had to buy a car, and I went to Honda showroom, pick the car. Just one option. Honda showroom, pick a car. I don't know which car it was, whether it was a sedan, hatchback, minivan, 2-wheel drive, 4-wheel drive, red, green, yellow. I don't know. There was one car, I just picked it up. Only one option. Now I'm becoming more sensible buyer. I said, okay, I want to buy a Honda, and I have 2 options. I can buy a sedan or I can buy a minivan. S stands for sedan, minivan. Okay. So when I just picked up Honda. I'll just buy Honda, no matter what. Be it a Honda Civic or be it a Honda Pilot. Only one option. Now, when I said, okay, fine, I will choose between, when I went to Honda showroom, first thing I said, okay, fine, tell me what are the different models you have. They said, okay, we have sedan and we have minivan. Okay. So now, earlier I had only one option. Now, how many options I got? Honda sedan as one option or Honda minivan as another option. Honda minivan is nothing but the Odyssey. So I can go for Honda sedan or Honda minivan. So I have got 1 into 2, this many options. Yeah. Now I said, okay, fine. Honda sedan or minivan. How about checking different brands? If I go to Toyota also, I get sedan and minivan both. So now, in the first place, I have two brands to pick from. See, sorry about that. See, this is the nuances that come with the AI. When I show the fingers like this, you will see the balloons popping. Okay. Now, when I have two brands to pick from, and every brand gives me 2 options, I got 2 into 2. Right? Now, if I say sedan, minivan and truck, for Honda I will get sedan, minivan or truck, 3 options. Toyota will get sedan, minivan and truck. How many it became? 2 times 3. So see, what is happening is, every level of option you are been given, that keeps on getting multiplied. Now imagine you got Honda, Toyota, and you got sedan, minivan and truck. Now how about, come on, sit down. You are 2 minutes early. Okay, sit down. Now imagine you have 2 colors also. You can choose blue or you can choose green. Now see here. So all the kids from the level 1, just hold it for 2-3 more minutes. I'm just concluding something for the senior kids and then we'll start your class. So here, when I had only blue to choose, I had 2 into 3 into 1. Now, if I have blue and let's say green both, so for every combination of Honda sedan, blue, green, Honda sedan, blue, Honda sedan, green, Honda minivan, blue, Honda minivan, green, it got doubled. So what is happening essentially here is that more the options, more the breakdown, that is actually multiplying. If you had only one color, this would have been 2 into 3, that many options. If you have 2 colors added, it becomes 2 into 3 into 2, 12. If let's say you have black option also added here, it becomes 2 into 3 into 3. So that is how this works. So going back to the question that I was asking you guys, that you have Honda, Ford, Toyota and Volkswagen, and each of them have blue, green, whatever, blue, black and white, three color options, and then among them all you have 2-wheel or 4-wheel. So what you see is, first level of information gives you 4 options. For every one of them you have 3 options, so 4 times 3, that many options you have. And then among those options also you can choose 4-wheel versus 2-wheel. So that means here you have 4 options, here you have 3 options, and here you have 2 options. The total number of options that becomes is by getting them multiplied. So 4 times 3 times 2. So like you saw, Honda only one option, Honda black, blue, or black, green, 1 to 2 options. Then Toyota comes into play. The whole thing gets multiplied by 2. So 2 times 2, 4, right? So that is the correlation. We took a lot of time to kind of decode this, to understand how do you come up with the maximum number of options you have from the different combinations or different the breakdown points, right? So the starting point is the complete superset, all the options that you have. If you have 3 things to pick from, what is the total number of options you have? And then the next level would be, how do you come up with different permutations by juggling them? And then next thing will be like, how do you want to eliminate some of the options and say, okay, fine, out of 5, I'll pick only 3 features, and then how many options do I have? Versus 4 features, how many options we have? So that is where we'll go to combination and permutation. Bless you. So net, so far we have only scratched the surface to understand what is probability, what is permutation, what is combination at a concept level. Then we started digging into it to look at what is the wider range of options or the possible options I have, and then how do we calculate mathematically. So we just started it. So we'll do a few more sums tomorrow, and then we'll look at permutation, and we'll continue with our journey of learning this topic. So this will not be a very straightforward topic. There'll be more practice, more ways to relate things, but if we understand the basic lay of the land with respect to what is probability, what is permutation and combination, I think we'll be able to use that for solving problems in the coming days. Are you guys with me so far? Was that confusing enough? Or
I
got it? Okay. Alright, so that brings us to the end of the class. I will let you guys go. Enjoy the rest of your evening. We'll meet again tomorrow, and we'll continue with our journey with respect to understanding probability, permutation, and combination.